So in this lesson we're going to talk about converting between mixed number fractions and improper fractions. And it's basically a way to communicate the size of the parts and how many of those parts there are. Now in these pictures here we can see we've got 4 wholes and we've broken them up into 8 pieces each. 1, 2, 3, 4, 5, 6, 7, 8. So we can talk about these pictures representing eighths. And essentially eighths are written with the 8 on the bottom. So if I'm talking about an improper fraction, I'm talking about a number where the number on the top is bigger than the number on the bottom. So 31 eighths can be represented also by looking at the number of wholes there are in this. So what I mean is 31 eighths can be described in terms of pictures, okay? We have 31 of a particular sized part, and that particular sized part is an eighth. So this here would be 1/8 if I shaded that in, because it is 1 out of 8. If I had to shade in 31 eighths, then I would need to shade in 8 eighths here. Whoop. And if I shaded this in, that would represent 8 eighths. Okay? And it's important to know here that whenever we see a number over the same number, it represents a whole. Okay, so this is 8 eighths. I've shaded in 8 eighths, but I want to shade in 31 eighths, so I need to shade in another 8 eighths. Okay, so far I've shaded in, I'll get rid of the 8 eighths now, because I've no longer shaded 8 eighths. So now I've shaded in how many eighths altogether? Well, 8 and 8 makes 16. So I've shaded in 16 eighths, and that's an improper fraction as it is. And obviously that's not 31 eighths. We want to get to 31 eighths. So I might need to shade in another whole or another 8 eighths. And now I would have shaded in not 16 eighths, but excuse me, 8 and 8 is 16 and 8 is 24 eighths. Okay, so here we've got pictures representing 24 eighths, but I want to shade in 31 eighths. So I need to shade a few more. So I've got 24 so far, so we'll go 25 eighths, 26 eighths, 27 eighths, 28 eighths, 29 eighths, 30 eighths, and 31 eighths. Okay, notice there's one left over. So I no longer have shaded my 24 eighths there, but I have shaded my 31 eighths, which is here. Okay, we represent that fraction as 31 eighths. We need to be able to rename these fractions, which means it's the same value but in a different name. And it's just a matter of thinking a little carefully about the pictures that they represent. Whenever you see these symbols, always think back to the pictures so it helps you think about what you're doing. It's a lot easier to think in pictures than in the symbols if this confuses you. So if I want to talk about then the mixed number fraction of that, so this here is the improper fraction. And we need to know this language so that you know what we're talking about when we're referring to particular types of fractions. But now we want to talk about the mixed number fraction. It's called mixed number fractions because we now have wholes that we can talk about. If we look at this picture, which represents the 31/8, we have a certain number of holes. We have 1 hole, 2 holes, and 3 holes. So 31/8 represents 3 holes, which we just write as the number 3, and 1, 2, 3, 4, 5, 6, 7 eighths left over. Whoop. So look really carefully at this. These symbols represent this picture. I have 3 holes and I have 7/8 left over. In fractions, we need to be able to talk about these different ways of naming fractions, so then we can add or subtract them later on. So just to make things a little more interesting, we could rename this fraction again in a different way. Let's say there are 2 holes. 1, 2 holes. Okay, how many eighths would there be left? Okay, we could say, well, there's 8/8 here and there's 7/8 there. So this fraction could be talked about as 2 holes and 15, if I add this 8/8 together to 7/8 and 15/8. Even though I have different numbers here, it all comes back to this picture. There are 2 holes and there are 15/8. I could talk about this fraction in another way. I could say there's 1 hole and there are 8/8 here. Another 8/8, which is 16/8 altogether. And 16 and 7 is 23/8, which is another way of talking about this fraction picture, which is our mixed number fraction. Okay, so we not just need to know the pictures all the time. Sometimes we just need to be able to convert between the symbols without the pictures, and this is a quick way to do that. 31/8 we can do by dividing our 31 by 8 and talking about a remainder. We can say that 8 goes into 31 how many times? Well, we've got 8, 16, 24, that's 3 times. So 8 goes into 31 3 times, so there's going to be 3 holes, and there's going to be some left over. If 8 3s are 24, 8, 16, 24, then what's left over? So 24 to 31, 25, 26, 27, 28, 29, 30, 31. You can count them on your fingers, or you can look at the difference between 24 and 31. 24 to 30 is 6, add 1 is 7. And we say that there are 3 holes and 7/8 left over. It's not letting me do my 8 very well, is it? So 3 holes and 7/8 left over. Okay, and if I go back up to what we did before, you can see there's my 3 holes and my 7/8. We've just done it without the pictures. But if you still need to draw some pictures to help you, please do. Okay, and if I'm going back the other way, so if I have 3 holes and 7/8, and I need to convert that into a mixed number fraction at any time, this is one way I could do it. It's called timeless, okay, which basically means we times and then we plus. So here we're going to, I'll use a different color, we times the bottom number, 8, by 3, and then we're going to add that to 7. I might choose a different color there so you can see what I've done. So we're going to add 8 times 3, and then we're going to add that to 7. Okay, so do that over here. We're going to go 8 times 3 plus 7. And that's going to equal 8 times 3 is 24 plus 7 is 31. So the answer is 31/8. And that's a quick way of turning our numbers into improper fractions using the time loss rule. Sometimes, especially in the addition and subtraction that we've been looking at, we might have 3 and 7/8, and we might just need to take one of these wholes and turn it into 8/8 and add that to our 7/8. So in your head you need to be able to go, well, if I take one whole away from here and I get 2 wholes, then that other whole has 8/8 in it. I need to add it to my 7/8, and 8/8 and 7/8 gives me 15/8. So that's the other mixed number fraction, 17/8. That's 8, not very good, that I can use. And sometimes you might need to do that when you're subtracting numbers from each other. So say you had 1 and 8/8, not that you would have that, but you couldn't subtract 8/8 from 7/8, so you would need to rename this mixed number fraction as 2 and 15/8, so then you can subtract 8/8 from 15/8 and be left with 15 take 8/8 is 7/8, and 2 take 1 is 1. Okay, and that's just going back to what we did up here before, where we just knew we could write that representation, that picture, in different ways. Okay, it's just looking at the picture and knowing when I take a whole, I can cut that whole into as many parts as I want. And if I'm dealing with eighths, you've got to know what type of parts you're dealing with. It could be sevenths, it could be halves, it could be thirds, but if you're dealing with eighths, you need to then rename that whole into 8/8. Now, once you've looked at this and you've watched this video a few times to help you understand, I recommend that you draw some mixed number fractions, write the symbols, and draw the pictures and see if you just can talk about those fractions in different ways. So just like what we did here, that's what I think you should practice. Maybe think of 24/7 and see if you can draw that as pictures, write it as mixed number fractions in different ways, and just practice being able to write those fractions in different ways, even though it's representing the same picture. So if you've watched this video, I encourage you to do that now first before you go on to any of the other homework, just to get in your head how to make sure it all works.